Hello everyone, this is Jaime Rios back again. This is going to be part 3 of day 5 video. Now this lesson is going to be short and sweet for this video. It's just going to talk about the Pythagorean theorem. This is to show proof why we use right triangles. Now this example that I'm using right now is called the 3, 4, 5 triangle. Meaning if one side's 3, the other side's 4, the long side has to be 5. Now the reason I'm using this one as an example is first, the numbers are easy to work with. But second, if any of y'all have ever done in construction, worked in welding, they have a triangle that's called a 3, 4, 5. And it's a triangle they use for building, right? One side's going to be 3 inches, the other side's going to be 4 inches, and the long side that goes from side to side is going to be 5 inches. And what they do is they place it next to, when they have two, like say a board like this and a board like that, and they place it right there. And if it goes in there completely, meets in there, that means that that angle is a right angle. So I'm going to explain it. Why is it a right angle? So this right here is my right angle. I have one side that goes up, that's 3 inches. Another side I go across, that's 4 inches. What's the size going to be? And of course I said before it's going to be 5, right? But I can prove this using the Pythagorean theorem. Which, remember, the Pythagorean theorem is going to be the a squared plus b squared equals c squared. So if this side is a and this side is going to be b, what's the length for this side? And I'm just using just math. So a squared plus b squared equals c squared. A squared, which is going to be 3 squared, plus 4 squared equals c squared. Okay? Now squared, remember, this is saying not 3 times it by 2, but 3 times itself 2 times. Same thing with 4. Not 4 times it by 2, but 4 times itself 2 times. So of course 3 times 3 gives me 9. 4 times 4 gives me 16. 9 plus 16 is equal to c squared. When I add these two together, I get 25. Now 25 is equal to c squared. Now what this is saying is what number times itself 2 times, what number times itself can give me 25. And one way you can figure it out is by doing the square roots. The square root of c squared or the square root of 25, right? Because you're trying to find what number by itself can give you 25. Of course, this gives us 5. So this side's going to be 3, this side's going to be 4, and this side has to be 5. We call it a 3, 4, 5. And these are kind of triangles, construction triangles they use. They're in industry. And the reason they use it is because if one side is 3, the other side is 4, right? Where they both meet at, that's going to be a right angle. And just proving it back again on the other side. Say I have this side is 5 and this side is 4. What can this side be? And of course we've known it was 3, right? But finding the sides of a right triangle, we're working with this. This side is B, this side is C. Trying to find side A. And I'm just working this out just to prove why this side is going to be 3. Using the Pythagorean theorem. So starting off again, we don't know what side A is. We do know what side B is. We do know what side C is, right? So using the Pythagorean theorem, which is a squared plus b squared equals c squared. So a is going to be x squared, which a number we do not know, plus 4 squared, which we know is 16, equals 5 squared, which is 25, right? And this is where the algebra comes in place. If I want to solve for x squared, I must move this number to the other side. So I'm just going to subtract both sides by 16. Minus 16, minus 16, right? These sides will cancel each other out. Of course, 25 minus 16, that gives me 9. Now what I'm saying is, what number times itself can give me 9? Of course, I'm going to do the square roots on both sides. And x has to be 9. Of course, 3 times 3 gives me 9. And that's the end of part 3. Stay tuned for part 4.